Next, that is transformation of straight line. Transformation of straight line. So first we are going to see how we can represent a line in 2D. How we can represent a line in 2D. So a straight line can be defined by two position vectors. A straight line can be defined by two position vectors. Two position vectors. We consider two position vectors. What are these? These are the end points of the line. What are these? These are the end points of the line. We consider these two position vectors are A and B. We consider here, for example, A and B. Okay, so on this we are going to see a line. A and B. A is the first starting point we can consider, and B we consider as a end point. A and B, these are the two end points. For example, suppose A is equal to 0, 1 and B is equal to 2, 3. B is equal to 2, 3. So on this diagram, the x and y coordinate, how we can represent? A is 0, 1. 0, 1 means this is, correct? That is A. Which is it? 0, 1. What is it? 0, 1. And what is the another end point? 2, 3. 2, 3. It is here. That is point B, 2, 3. Now I draw a line from here to here, straight line. Okay. This is point B and this is point A. This is point B and this is point A. So in this way we can represent a line. A is equal to 0, 1 and B is equal to 2, 3. Now again it is a 2D transformation. So transformation matrix for this is A, B, C, D. 2 into 2 matrix. 2 into 2 matrix. See with example. Now transforming this line with two endpoints A and B with some transformation matrix, we give a new line with new points. That we call it as a new points as A star and B star. We call these new points as A star and B star when we transform this line. Consider, let example, first we A and the transformation matrix T. What is our A? 0, 1. We consider a simple transformation matrix 1, 2, 3, 1. Tell me the result. What are the new points? It is 3, 1. It is 3, 1, which is equal to a new point A star. Same B multiply with transformation matrix T. What is our B? 2, 3. Multiply with this transformation matrix. We will get the result 11, 7. That is our new B star. That is our new point B star. Or the same you can write it in single way. That is L represent line. What is this L represent? Line. T transformation matrix. We represent it like this. First A, then B. First row indicates A, second row indicates B, and multiply with the transformation matrix. In this way we can do it also. So first row A multiply with the first column. First row multiply with the first column. We will get the same result. 3, 1, 11, 7. That is L star. That is L star. Now draw it here. What is first point? What is A star? 3, 1. 3, 1. It is here. And what is? It is 11, 7. I need to draw here. 6, 7. 8, 9, 10, 11. And here 6 and 7. So 11, 7. It is somewhere here. Okay. And this is our new line. A star with 3, 1 and B star with 11, 7. X is 11 and Y coordinate 7. So what we observe here? What happens here in this case? Here it is the enlargement of the line and also change in the origin. Also change in the origin. So where the components of L star represent the transformation of line L, in this it is a sharing transformation. It is scaling. It increase the size of the line along with change in the origin. Along with change in the origin. Now see another example. Instead of, why it is enlargement here? Because B and C both are greater than 1, or all the values are greater than 1, and that's why it happens. If it is less than 1 or greater than 0, if it is less than 1 and greater than 0, then in that case it decrease the size of the line. It decrease the size of the line.
Midpoint transformation. Midpoint transformation. So in 2 into 2 matrix, we are using for a line 2 into 2 transformation matrix. So a 2 into 2 transformation matrix transform any straight line into second straight line, that we have seen in the previous lecture, that any transform any straight line into a second straight line. Then points on the second line, see, points on second line means the line which is transformed have a 1-to-1 correspondence with points on first line. Okay, the points on the second line have a 1-to-1 correspondence with points on the first line. How to show it? And for that, to confirm this, that every point correspond with the another point, to confirm this we consider transformation of midpoint. Transformation of midpoint. Okay. So here we are going to show that the midpoint of first line is correspondence with the midpoint of second line or transformed line. That we are going to prove here. Okay. So here let A is equal to x1 y1 the first end point or the first point of the line, and B is equal to x2, y2, the second end point of the line, and the transformation matrix T is equal to A, B, C, D. T is equal to A, B, C, D. After now we are going to transform both the endpoints simultaneously or transform the entire line. So after transformation of line, after transformation of line, how we perform it? A, B multiply with T. So what are the points of AB? x1, y1, x2, y2, and then A, B, C, D. Now perform the multiplication here. What is the result we will get here? Multiply this first row with the first column, this row with this column, then multiply this row with this column. So in this way we will get multiply x1, y1 with A and C. So we will get A of x1 plus C y1. Then multiply x1, y1 with B and D. So we will get B of x1 plus D of y1. Second, multiply x2, y2 with A and C. So we will get A of x2 plus C of y2. And the second coordinate, B of x2 plus D of y2. It is equal to the new line or the transform line A star B star with new endpoints A star B star. Now, hence the endpoints, how we write here? Hence, the endpoints of transformed line A star B star are this is the new line, correct? AB we transform into A star B star. So hence the endpoints of the transform line A star B star are, I write here the endpoints. A star is equal to, what is A star here? A of x1 plus C of y1 and B of x1 plus D of y1. And what is B star? It is A of x2 plus C of y2 and B of x2 plus D of y2. That is B star. Now we calculate the midpoint of this transform line. Okay. Now we calculate midpoint of transformed line. We calculate the midpoint of transform line using these endpoints. Endpoints are available. So I write here for midpoint xm star because these are the midpoint of transform line. How to calculate it? The midpoint x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So if it is a line like this, how to calculate the midpoint? It is x1 y1 and this is x2 y2. So how to calculate it? X1 plus x2 divided by 2 and y1 plus y2 divided by 2. So in this way we calculate the midpoint of any straight line. So using this formula, it is x1 star plus x2 star divided by 2. Sorry. And y1 star plus y2 star divided by 2. Okay. Now I use it as the equation number 1. these two as the equation number 2. Okay. Before that, I write here for simplicity. It is equal to x1 star, y1 star, and it is equal to x2 star and y2 star. Okay. So the midpoints are x. This is equation 2 and this is our equation 3. Now the midpoints, how we calculate it? x1 star plus x2 star divided by 2 and y1 star plus y2 star divided by 2. Now we put these values of x1 and y1 star and x2 and y2 star here. What is x1 star? Ax1 plus cy1 and x2 star this one. So I put this value here. This is a of x1 plus c of y1 plus what is x2 star? It is here a of x2 plus c of y2 divided by 2. Correct? And what is y1 star? b of x1 plus d of y1 divided by plus y2 star. It is b of x2 plus d of y2 divided by 2. So is it clear up to this? Now we try to simplify it. So a of x1 plus c of y1 plus a of x2 plus c of y2. So we try to minimize this. We keep a as common, x1 plus x2, all our plus signs are, no minus sign is there, divided by 2 plus c of y1 plus y2 divided by 2. Okay. Then here also b we can make it common, b of x1 plus x2 divided by 2 plus d of y1 plus y2 divided by 2. That is our equation number 4. That is our equation number 4. Board. Now see, this is x m star and y m star. What is it? It is the midpoint of transformed line. These are the midpoints of transformed line. Okay. Now we are going to calculate the midpoint of original line AB. So midpoint of original line AB is, how to calculate the midpoint of original line? The equation is same. xm ym is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So these are the midpoints of original line. We call it as the equation number 5.
Okay.
Midpoints of original line are x1 xm ym is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Using this transformation matrix, T, using transformation matrix T, we transform this midpoint. We transform only this midpoint. So transform this midpoint with the T. So xm ym multiply with T. What is xm y1? Ym x1 plus x2 divided by 2 and y1 plus y2 divided by 2 multiply with the transformation matrix A, B, C, D. Multiply with the transformation matrix A, B, C, D. So multiply this one row with the first column A and C. So it is A of, multiply this x1 plus x2 divided by 2 first with A. So A of x1 plus x2 divided by 2 and then multiply x1 x2 with C. C of x1 plus x2 divided by 2. Now multiply this row with the second column B and D. So it is B of x1 plus x2 divided by 2 and plus D of y1 plus y2 divided by 2. Now observe this one. This we call equation number suppose 6. Equation number 6. Now observe this equation number 6 and the equation number 4. Observe equation number 4 and equation number 6. What do you observe here? Both are same. Both are same. Means the midpoint of transform line is equal to this value. Okay. The midpoint transformation of original line is equal to the midpoint of transform line from the equation 4 and 6. And that's why we can say every point on the first line is correspondence with every line with the second or the transform line. So comparing, I write here comparing equation 4 and equation 6. What we observe that it shows that they are identical. It shows that they are identical. Means what? It shows that the midpoint of line AB transform into the midpoint of line AB star. Transform into the midpoint AB star. So see once again, I will explain it in short. Here what we have to show that every point on the first line is correspondence with the every point on the second line. Correct? So to confirm this transformation of midpoint, or we use the transformation of midpoint. For that, first we take a simple line AB and multiply with the transformation matrix ABCD. So we will get this first AX1, BX, whatever these values, that is the transform line A star and B star. Now these are the end points of the transform line A star and B star. A of x1 plus C of y1, B of x1 plus D of y1, that is x1 and y1 star. Similarly, B star has the end points x2 star and y2 star. Now the end points of the transform lines are available. With that we can calculate the mid. What is the simple equation to calculate the mid? Xm star ym star is equal to x1 star plus x2 divided by 2, y1 star plus y2 star divided by 2. Now we put these values here in this equation. Okay, so here we put these values in this equation, that is x1 y1 star, x2 and y2 star. These values, after putting this and try to simplify it, we will get the result. That is the midpoint of transform line. Now to show it correspondence with the midpoint of original line, we calculate the midpoint of original line AB. What is the midpoint of original line? It is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. It is equation number 5. Now using transformation matrix, we transform this midpoint, multiply this midpoint with transformation matrix, we will get the result. Okay, so we will get this result: a of x1 plus x2 divided by 2, c of x1 plus x2 divided by 2, and b of x1 plus x2 divided by 2, and d of y1 plus y2 divided by 2. So if we observe the equation number 4 and equation number 6, 4 and equation number 6, both are equal. So it shows that the midpoint of line AB transform into the midpoint of line AB star. Original line are correspondence with each other. So consider example here, one simple example we will see here. Consider the line AB with points or end points. Consider a line AB with end points. A is equal to 0, 1 and 0, 1 and B is equal to 2, 3. The transformation matrix T is equal to 1, 2, 3, 1. After transformation, now we transform this line, straight line AB, using this transformation matrix. So, after transformation of line AB, the new line endpoints are A star, B star, correct? So here we write these calculations. A, B multiply with T. What are the values of A? 0, 1 and the values of B are 2, 3. Multiply it with the transformation matrix 1, 2, 3, 1. So we will get the result 3, 1, 11, 7. Use the simple method, row multiply with column, and it's addition. So here we will get the new endpoints of the transform line A star and B star, that is 3, 1, 11, 7. Now calculate the midpoint of A star and B star. The midpoint of A star and B star is, so midpoint xm star and ym star. As it is a transform line, so we use the asterisk symbol. I am calling here star, it is asterisk. Xm star, ym star means the midpoint of the transformed line. Okay, midpoint of transformed line. Calculate it. What is the equation? X1 star plus x2 star divided by y1 star plus y2 star. So it is x1. I write it here for simplicity. X1 star, y1 star and x2 star, y2 star. So put these values here. 11, 3 plus 11 divided by 2 and 1 plus 7 divided by 2. So we will get the value 7 and 4. We will get the value 7 and 4. So these are the midpoints of transformed line, correct? Now we calculate the midpoint of original line. And then we transform this midpoint of original line AB is, that is xm ym is equal to x1 y1 plus x2 divided by 2 and y1 y2 plus divided by 2. So what is x1 here? This is x1, this is x2. x1, x2, y1 and this is y2. So add it. 0 plus 2 divided by 2, 1 plus 3 divided by 2. So it is equal to 1 and 2. It is equal to 1 and 2. So what is it? This is the midpoint of original line AB. Now we transform it with the transformation matrix. So using the transformation matrix, transform the midpoint. Transforming this midpoint. xm ym multiply with t. 1, 2 multiply with the transformation matrix. What is the transformation matrix? 1, 2, 3, 1. Now calculate these values. 1 plus 1 plus 6, that is 7. And 2 plus 2, 4. 2 plus 2, 4. Now this one, this is the transformation of the midpoint of original line, correct? And this is the midpoint of transform line. I write here equation number 1 and write here equation number 2. So observe the equation number and equation number 2 both are same. Means what? Whenever we transform any straight line into another straight line, the points are correspondence with 1 to 1. Now the next one, transformation of parallel lines. Transformation of parallel lines. If there are two parallel lines and if we transform it, then what happens? When a 2 into 2 matrix, when a 2 into 2 matrix is used to transform a pair of parallel lines, the result is the second pair of parallel lines. When a 2 into 2 matrix is used to transform a pair of parallel lines, then the result is the second pair of parallel lines. Here we consider for this, consider a line AB with endpoints A is equal to x1 y1 and B is equal to x2 y2. B is equal to x2 y2 and line AB is parallel with line EF. There is another line EF which is parallel to line AB. Now two lines are parallel. These two lines are parallel. So to show these parallel lines and they are transformed into the parallel lines, we need the slope. Okay. Since AB and EF are parallel, the slope of both are same. And how we calculate the slope? M is equal to x2 minus x1 divided, y2 minus y1 divided by x2 minus x1. Means the slope of both the lines are equal. Now we find out the endpoints of transformed line. Okay. Now we transform the line AB into AB star. Only we are going to see for AB, not necessary to see for EF, because both have the same slope, and using the slope we are going to show it. Now we transform the line AB into AB star using the transformation matrix. X1, Y1, Y1, Y2, X2, Y2, A and B multiply with the transformation matrix A, B, C, D. So we will get the result that already we have written it many times. A of X1 plus C of Y1, B of X1 plus D of Y1, A of X2 plus C of Y2, and B of X2 plus D of Y2, which is equal to A star B star, means the new transform line, and the new endpoints are X star Y star. You can call it as a asterisk. Actually it is known as asterisk symbol, and this one. So that is our second equation, that we transform the line AB into AB star. Using equation 2, which are the endpoints of the AB star, we calculate the slope of new transformed line. Now we calculate the slope of, using equation 2, calculate slope of A star B star. Okay, calculate slope of A star B star. Then M star, we call it as a slope M star. How we calculate? Y2 minus Y1, X2 minus X1. Y2 is B of X2, this Y2 minus Y1 star. So B of X2 plus B of Y2 minus B of X1 plus D of Y1 divided by X2 star minus X1 star. What is X2 star? A of X2 plus C of Y2 minus A of X1 plus C of Y1. X2 star minus X1 star. Or I write it here. Again the equation M is equal to Y2 star minus Y1 star divided by X2 star minus X1 star. Okay. Now try to simplify it. I keep B as a common, that is X2 minus X1 plus D as a common, Y2 minus Y1 divided by A we kept here common, or X2 minus X1. Now D is, C is common here, C y2 minus y1. Again we simplify it here. The slope of transformed lines m star is equal to b plus d. We write it in y2 minus y1 divided by x2 minus x1 and divided by a plus c y2 minus y1 divided by x2 minus x1. Is it correct? Which is equal to, now which is equal to, so this one are same. So remaining, what is that value? y2 minus y1 divided by x2 minus x1. It is m. y2 minus y1 divided by x2 minus x1 is equal to m. That is, we have written in equation number 1. So from equation number 1, we simplify it b plus d of m, a plus c of m. Again, we will require this equation in intersect line intersection. Okay, transformation of intersecting line. So that is equation number 3. We simplify. This is the slope of transform line. Now, in this slope of transform line, what is it? B plus dm divided by c plus m. What we observe here in this equation number 3, where we calculated the slope of transform line, we observe that here this slope of transform line, I write it here, slope of transformed line A star B star is the slope. This is the slope of transform line A star B star. So the slope of transform line A star B star is independent on which values? It is independent of x1, x2, y1, y2. It is independent of x1, x2, y1 and y2 and depend on which values? A, B, C, D and M. Correct? See, once again I am repeating. The slope of transform line, that is M star, is independent on x1, x2, y1, y2 but dependent on A, B, C, D, M. Since A, B, C, D and M are same for AB and EF, it shows that M star is same for A star, B star and E star, F star. Okay, see, once again I am repeating that the slope, since A, B, C, D, M are same for the original line AB. Suppose this is AB, EF. The slope, these are same for AB and EF. Why? ABCD is the transformation matrix which is same and M is the slope. As these are two parallel lines, the slope is same. Then if we transform this line in the two lines, A star and B star, E star and F star, then these are same for here. Why? ABCD is same, transformation matrix is same, and as M star is independent of x1, y1, x2, y2, this M star is also same. Means the slope is also same. So it indicates that the transformation of two parallel lines result in the transformation of another two parallel lines. Means parallel lines remains parallel after transformation.